Alright, so moving on to what number is this? Number 6. I got thrown off by this number 5 right here. I knew it was number 6. And we're going to evaluate the following limits. So we have this image here, okay, and this is the limit that we have to evaluate. And there's nothing else, right? Okay. So I'm just going to copy this over. So we have the limit as x goes to 1 over 4 of 1 minus 4x over the square root of x minus 2x. Okay. So what do we know about limits? The first thing we could try to do is we can just plug in what we are evaluating the limit at. So let's try plugging it in. So if we get 1 minus 4 times 1 over 4 over the square root of 1 over 4 minus 2 times 1 over 4, we end up getting 1 minus 1 over 1 half minus 1 half, and we get the classic 0 over 0 case. Now, what's good about the 0 over 0 case is that if both the numerator and denominator are differentiable and we have this 0 over 0 case, we can use L'Hopital's rule. So the condition is we have to get that undefined 0 over 0, plugging in the value at which we're taking our limit, and you have to be able to differentiate the top and bottom. So we can differentiate the top and the bottom, the numerator and the denominator, and what we end up getting is the limit as x approaches 1/4 of minus 4, because derivative of a constant is 0, derivative of minus 4x is minus 4, over, we can write this as x to the 1/2 power. So taking the derivative would be 1/2 x to the minus 1/2. And then we get minus 2, derivative of minus 2x is minus 2. So this is actually, I'm going to write this x to the minus 1/2 as 1 over square root of x, and then minus 2. Now we could see if we could plug in our 1/4 into this and actually get either a truly undefined, or a truly limit does not exist if we have a constant over 0, or any other value. So let's try plugging it in. So we get minus 4 as a constant on top, over 1/2 times 1 over square root of 1/4 minus 2. And this is going to give us minus 4 over, so the square root of 1/4 gives us a half. 1 over a half is 2. 2 times 1/2 is 1 minus 2, which is minus 4 over minus 1, which is 4. So because we were able to evaluate this limit after L'Hopital's rule, we found that our limit is equal to 4. So I'm just going to write that in here. So after using L'Hopital's rule once and substituting in for x equals 1/4, we find that the limit evaluates to 4. Good suggestion for L'Hopital's. Okay. And that would be sort of correct.